Hey students, we're going to go over how to calculate the percent yield in this video. So the equation to calculate percent yield and information about theoretical yield and actual yield are already on your page 9 in your packet. And now in order to understand percent yield and what that theoretical and actual yield actually mean, I'm going to go ahead and talk about that first before I show you how to do those calculations. Theoretical yield is what you actually calculate from the amount of reactant that you started with in the problem. So you have to determine how much product you should have made. Okay, so when you do the stoichiometry sequence, that will tell you how much product you should have made. That is your theoretical yield. The actual yield is what we would obtain when we perform a lab. So for questions in a packet or on a quiz or a test, I would have to give you the actual yield, and it would be based off of some data that we were collecting from a lab, okay? A lot of times that actual yield is going to be less than what we should have expected because there's a lot of, inaccuracies with our measuring devices. There's some, loss of reactant or loss of product during the performance of lab or something to that effect. All right, so percent yield formula is going to be this. Again, it's on page 9 in your packet, but we're going to take that actual yield divided by the theoretical yield times 100 to get it into percent form. So when we look at this question here, number 7 on page 9, it says that we have 75 grams of carbon monoxide reacts to produce 68.4 grams of methyl alcohol. What's the percent yield? So we have the formula for you all already. It's carbon monoxide reacts with hydrogen gas to produce methyl alcohol. So when you look at this question here, this 75 grams of carbon monoxide, that's what we're going to be starting our stoichiometry with. That's how much we started in our actual experiment when we actually, completed a lab. It tells us that we produced 68.4 grams of methyl alcohol. That's going to be our actual yield. So that's what we would have obtained from data during our lab. We're going to use that at the end of our problem. The first thing that we're going to have to do is do some stoichiometry to figure out how much methyl alcohol we should have made. So we're going to start our stoichiometry with our 75.0 grams of carbon monoxide. Down here at the bottom, of course, we're going to put the molar mass of carbon monoxide, which is 28.01 grams. We'll have 1 mole of carbon monoxide up here on the top. Looking at our reaction here, we're going to use our coefficients to convert from moles of carbon monoxide to moles of that methyl alcohol. And we're going to finish this off by converting to the grams of the methyl alcohol that should have been produced, or the molar mass. Excuse me, let me get my calculator. So I've got 12.01 grams plus 4 hydrogens plus 16 grams for the oxygen. So 32.05 grams is our molar mass. All right, so when I go ahead and solve here, I'm going to get 85.8. 85.8 grams of methyl alcohol. Once you complete that stoichiometry, that is telling you your theoretical yield. That's how much you should have expected to make if you actually reacted 75 grams of carbon monoxide. But we only made 68.4 grams. So when we do our percent yield, the equation tells us that we're going to take our actual yield, so 68.4 grams, over our theoretical yield, which is 85.8 grams, times 100. All right, so we'll have our 68.4 divided by our 85.8. I always round my percentages to the hundredths place, so I would get 79.70%, and that would be my yield. Okay, so let's take a look at page 9, number 8. It tells us that we're we have 1.85 grams of aluminum reacting to produce 3.7 grams of copper. So looking at this information here, what would our actual yield be? Our actual yield is going to be this right here, the 3.7 grams of copper. So our equation is 2 moles of aluminum with 3 copper sulfates making 3 coppers and aluminum sulfate solution. Okay, so we're going to start our stoichiometry. What are we going to start our stoichiometry with? We're going to start our stoichiometry with that 1.85 grams of aluminum because when we did our reaction, that's what we actually start with. We start with our reactants. We have to have the molar mass of the aluminum down here at the bottom. We're going to have 1 mole of the aluminum up here. We will have 2 moles of aluminum because we have to use our coefficients to switch from moles of aluminum to moles of copper. Why are we going to go to copper up here on the top? Well, because our actual yield was the copper that was produced. And then we're going to have our 1 mole of copper here, and our molar mass of copper is 63.55 grams up here. So divided by 26.98 times 3 divided by 2 times 63.55. So that's going to give us 6.54 grams of copper. So remember, when you do your stoichiometry, you arrive at the answer. That's telling us how much product we should have made. So that is going to be our theoretical yield. So I'm going to find my percent yield. I take my actual given to me in the problem, so 3.70. I'm going to divide it by my theoretical, 6.54 grams times 100. And I would get 56.61. Now, if you get something a little different than me, it might be because I used the unrounded theoretical yield from the calculator instead of the rounded value. If your percents are a couple hundredths off, don't worry about that too much. All right, so that's how you calculate your percent errors, your percent yields. So if you have any questions, just let me know. Bye.